Okay, for each of these courses, there are always new findings being reported. So I will start to add a section called new findings for each topic, and starting with this cyclone one, I already added a couple for geoengineering and climate indices, for example. This one is a paper from the Indian Institute of Tropical Meteorology group, which reports that there are years when the cyclones are born in the Arabian Sea during the monsoon onset phase, and it is related to upper level westerlies intruding from the mid latitudes and creating conditions favorable for cyclones to grow. What is the favorable condition? Obviously, we said the North Indian Ocean has a pre-monsoon season and a post-monsoon season in terms of cyclones, and during the monsoon we know that the wind shear is too strong, so the convection that can actually be very conducive to cyclogenesis then doesn't lead to cyclones growing during the monsoon because of this strong vertical shear, as we learned before. So anything that favors the cyclones close to the monsoon onset then has to affect the vertical shear. So this paper is about what are the processes that can allow vertical shear to be weakened and allow cyclones to grow close to the monsoon onset. This is the number of the locations where the cyclones were born during the month of May, few pentads close to the onset during the years of 1979 to 2019, and you can see there are a fair number of them, some being born close up to the coast, and some a little bit away, and some in the middle, and some closer to the one or two closer to the African coast. Okay, you remember that the monsoon circulation begins to get set up. There is a strong southwesterly jet, the so-called low-level jet, which begins to get organized, and the Bay of Bengal monsoon onset happens earlier, and then there is the Andaman Nicobar monsoon that happens before the Bay of Bengal onset. So Bay of Bengal is warm and convecting during the pre-monsoon season quite a bit. Arabian Sea is warm, but the convection is typically much less than the Bay of Bengal, and it's the southwesterly jet that's beginning to advect in moisture. So what happens? Here are the composites of zonal wind anomalies at 200 hectopascal level in cyclone years during the pentads of May 11 to 15, 16 to 20, 21 to 25, and 26 to 30. So these are anomalies. So there are westerly anomalies, not systematically organized through these few pentads, but the main thing is that there is this strong anomaly which is hovering over the Arabian Sea, intruding into the Arabian Sea or over the Indian region, and these dashed pink contours here correspond to winds being stronger than 20 meter per second in the mean, right? Actual wind speeds. This is showing the impact of those intrusions of westerly winds, which is to cool the temperature averaged over this 1000 hectopascal, which is basically the surface, to 500 hectopascal, which is middle of the troposphere. And what does that do? You remember that the monsoon onset is related to the meridional temperature gradient in the troposphere, averaged over the ocean region and over the continental region, subcontinent, and that gradient goes from negative to positive when the monsoon onset happens. Anything you do to weaken the northern tropospheric temperatures is going to weaken the north-south gradient and weaken the monsoon circulation, in our case the southwesterly jet, which means it will weaken the vertical shear. So the other thing that happens with this weakened monsoon circulation is that there is much more anomalous convective activity over the Arabian Sea, and the convective activity over the Bay of Bengal is suppressed because that weakened circulation is reducing the moisture supply to the Bay of Bengal convective activity. So looking at the same pentads in terms of OLR anomalies, which are an indicator of deep convection, you can see that the Bay of Bengal is positive, which means deep convection is reduced. Remember, deep convection, tall clouds, cold cloud top temperatures, and lower OLR. So higher OLR means reduced convective activity. The Arabian Sea, on the other hand, is seeing anomalously high convective activity as seen by anomalously low OLR. Again, you see Bay of Bengal remains positive. So this is the key message. Okay, and you can look at the zonal wind anomalies that indicate that the monsoon circulation is indeed weaker during these episodes when the westerly wind anomalies in the upper troposphere are modulating the tropospheric temperature or the monsoon region and the northward temperature gradient, and then the circulation. So you can see these easterly anomalies in the lower level at 850 hectopascal during these pentads coming close to the monsoon onset means that the southwesterlies are weakened, anomalously weak, okay, especially here in these two pentads as well as here, okay, and this also results in weakened vertical wind shear, which is favorable for cyclones to grow. So you can see the anomalies here in terms of weakened vertical shear over the monsoon trough region, which is trying to move in from this direction here. So the weakened vertical shear is then going to allow the cyclogenesis that happens because of the convective activity over the Arabian Sea. Convection is always able to put down vorticity anomalies at the surface, which can grow by feeding on the ocean energy. Ocean is warm during this time. Only after the monsoon onset, when the southwesterly jets really becomes very strong, that the Arabian Sea begins to evaporate and have upwelling and ends up with cold temperatures. So the final point is then look at the OLR anomalies going into the monsoon season. So June 1st is typically the onset. Of course, it has large interannual variability, but the point here is that the very high convective activity indicated by significantly low OLR anomalies compared to the high OLR anomalies in the Bay of Bengal, where convection is suppressed, is going into the monsoon, and you would think that would delay the onset, but you can see the monsoon trough or the convection associated with it beginning to organize here compared to here, or at least moving northwestward. And this is of course associated with cyclones, which have a lot of convection. We have talked in the other podcasts about the cyclonic circulation of the cyclones themselves pulling the monsoon trough. So even with a weaker circulation, favorable for cyclone formation but not favorable for monsoon onset over the Bay of Bengal. Are the anomalous circulations of the cyclones pulling the trough and then the onset, making the onset occur on time? Seems like that's what happened in 2020 and 2021, but this is to be investigated further with data and models and so on. So this is a nice story of how extratropical interactions are able to change cyclogenesis and cyclone numbers and growth during phases where the conditions are actually unfavorable in general, but the mid-latitude interactions make them favorable. Of course, the next question is whether the mid-latitude intrusions are changing because of global warming, and whether warmer Arabian Sea is then favoring more cyclones during the pre-monsoon. We have talked about the trends. There is a slight increase. The increase is much more prominent in the post-monsoon season, but here we are talking about the pre-monsoon season. So these other questions about relation with global warming has to be looked at with models and so on, and I will report it later if somebody publishes results on that.